All right, so on to this next page. For our warm-up, we're going to be looking at some of the problems that we did in our last unit. So those are multiplying these binomials together. I'm going to do the work for them over here on the side, just because we don't have room. So this first one, we would have x plus 1 times x plus 5, and multiply to fill in this box. This would be x times x, which is x squared. This one would be x times 5, which is 5x. This one would be x times 1, which is 1x. And finally, 1 times 5, which is 5. So once we have each of these, we would just add them together. This would be x squared plus 5x plus 1x plus 5. We combine our like terms. 5x and 1x would give me 6x. This gives me x squared plus 6x plus 5. So when I multiply x plus 1 times x plus 5, that would give me x squared plus 6x plus 5. Okay, for the next one, I have m minus 4 times m plus 6. So we would have m minus 4 and then m plus 6. And again, draw this box to multiply in. In this box, m times m would give me m squared. In this one, m times 6 would give me 6m. This one, m times negative 4 would give me negative 4m. And on the last one, negative 4 times 6 would give me negative 24. So then we would have m squared plus 6m minus 4m minus 24. Our like term, 6m minus 4m would be 2m. So we're going to have m squared plus 2m minus 24. So this one we can multiply out to m squared plus 2m minus 24. Okay. So for the last one, we have k minus 7 times k minus 3. K times k is k squared. K times negative 3 is negative 3k. Negative 7 times k is negative 7k. And negative 7 times 3 is 21. So this will give me k squared minus 3k minus 7k plus 21. Combine our like terms. Negative 3k and negative 7k is negative 10k. So now we have k squared minus 10k plus 21. So this becomes, when we multiply these, k squared minus 10k plus 21. Yeah. So those are the types of problems that we would have done in our last unit. In this unit, we are going the other way around. So instead of multiplying these together to get this as the answer, we are going to be taking the x squared plus 6x plus 5 and turning it back into this multiplication, x plus 1 times x plus 5. Or the m squared plus 2m minus 24, we're going to turn that back into m minus 4 and m plus 6. We're just undoing the multiplication that we would have done in the last unit. And then k squared minus 10k plus 21, we would turn into k minus 7 and k minus 3. So now we need to know, how do we actually do that? So to factor a trinomial of the form x squared plus bx plus c, we need to find two integers. Integers essentially just means the whole number, but it can be positive or negative. And they need to multiply to c and add to b. So c and b we can find from the equation. C is going to be the last number, or the one that doesn't have the variable. And then b is going to be the number in front of x, or in front of the one that's the variable, but not the variable squared. But this kind of thought should sound familiar to you. We need numbers that multiply to c and add to b. That's the kind of thinking that we were just doing on this paper with the x. We needed numbers that multiply to 16 and add to 10, or numbers that multiply to 16 and add to 8, or up here, numbers that multiply to 3 and add to negative 4. So that was the same kind of thing we were just doing on that paper with the x. For this example, x squared plus 7x plus 12, and the 12 would be c. So let me do that with a pen. The 12 would be c, and the 7 would be b. So what I would do for this problem is I would set up an x, just like we did on the previous page. I would put 12 on the top, and I would put 7 on the bottom. And now we need to find numbers that multiply to 12 and add to 7, just like we found on the previous page. Okay, so again, I would go to that factor sheet and find the numbers that multiply to 12. Those would be 1 times 12, 2 times 6, and 3 times 4. So looking at these pairs, I'm looking for one that adds to 7. Looks like these would be my pair that add to 7, 3, and 4. So the two integers that have a product of 12 and a sum of 7, those would be 3 and 4. Okay. So once we have those numbers, those are the numbers that are going to be in the parentheses with our variable like this. All right. All these numbers that I just underlined are what these numbers are going to be when we factor. So if I have x squared plus 7x plus 12, and I find these numbers 3 and 4, that's going to give me the factors x plus 3 and x plus 4. And we can confirm that we did it correctly if we do this distribution to check. Distribute, again, just means multiply. So we can multiply our answer back out to check to see if we did it correctly. I have x plus 3 times x plus 4. So let's set that up. X plus 3 times x plus 4. X times x would be x squared. X times 4 would be 4x. 3 times x would be 3x. And 3 times 4 would be 12. So this gives me x squared plus 4x plus 3x plus 12. We combine these like terms. 4x and 3x is 7x. This gives me x squared plus 7x plus 12. And if I look at that, that is the same thing that I had at the beginning. And so I can tell that I did factor this correctly, because when I multiply it back out, I get what I started with. Okay. So this is what we're going to be doing for all of these problems. Again, as a reminder, I will be doing these odd ones as the notes. You will be doing the even ones as your assignment. So for each of these problems, what I'm going to do is set up one of these x's to solve. Right? Each problem, we're going to set up one of these x's. The number that's going to go on top is going to be this last number. So the 20 would go on top for this one. 24 would go on top for this one. Negative 18 would go on top for this one. And negative 6 would go on top for this one. Okay. What goes on the bottom would be b, which is the middle number, or the number in front of our variable. So for this one, it would be 9. For number 3, it would be 10. For number 5, it would be 3. For number 7, this one's a little bit trickier. We got to look for the middle number, but that number in front of the g would be a 1. So that would be 1 that goes on bottom. Okay. So now that we have our x's set up, what we need to do is find the numbers that multiply to the top and add to the bottom. So I need to find numbers that would multiply to 20. That's 1 times 20, 2 times 10, or 4 times 5. And then we need to find the ones that would also add to 9. So that looks like that would be 4 and 5. 4 times 5 is 20. 4 plus 5 is 9. So this is going to give me factors n plus 5 and n plus 9. Let's do that better. Okay. On to number 3. I need numbers that multiply to 24. And so those are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So then we need the ones that multiply to 10, or sorry, that add to 10. So it looks like the ones that would add to 10 would be 4 and 6. So that's going to give me factors a plus 4 and a plus 6. Okay, on to number 5. I need numbers that multiply to negative 18. So the numbers that multiply to 18 are 1 and 18, 2 and 9, and 3 and 6. But if I need to multiply to a negative 18, that tells me that one of these numbers is going to have to be a negative. Okay. So it's either going to be negative 1 and 18, negative 2 and 9, negative 3 and 6, or it could also be, let me move this over so I have more room. It could also be 1 and negative 18, 2 and negative 9, or 3 and negative 6. But some combination of one positive and one negative number is going to get me to negative 18. So the ones that would add to a positive 3, that would be the negative 3 and 6. So negative 3 and 6 would multiply to negative 18 and add to 3. So that gives me n plus 6 and n minus 3. That's my factors. Okay, on to number 7. We need numbers that multiply to negative 6. So again, that tells me that one of my numbers needs to be negative. So I want to multiply to a negative 6. The numbers that multiply to 6 are 1 times 6 and 2 times 3. So again, one of those has to be negative, either negative 1 and or negative 1 and 6, negative 2 and 3, or it could be 1 and negative 6, or 2 and negative 3. The ones that would add to 1 would be negative 2 and 3. And so that's going to give me the factors g plus 3 and g minus 2. Again, don't forget that your assignment and your practice problems are going to be these even ones. So 2, 4, 6, 8. Make sure you are working through these ones on your own time as well. But then I'm going to go ahead and continue on to the backside. Okay, so I'm not going to do all of these ones on the backside, but just a couple. On number 9, I would set up the x and negative 3 would go on top, and negative 2 would go on the bottom. So I need the numbers that multiply to negative 3. Again, that tells me one of the numbers will need to be negative. The numbers that multiply to 3 are 1 and 3. So if one of those has to be negative, the ones that would give me to negative 2 would be 1 and negative 3. So that will give me the factors a plus 1 and then a minus 3. So now I'm going to go on to number 13. On number 13, I'd set up this x where 24 would go on top and negative 11 would go on the bottom. Now if I need to multiply to a positive 24, and add to a negative 11, that's going to tell me that both of my numbers need to be negative. Because in order to multiply to a positive 24, we either have to have a positive times a positive or a negative times a negative. And if I'm adding to this negative 11, that means that both of them are going to have to be negative in order to be able to add to negative 11. So the numbers that multiply to 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. But again, remember, for this one, both of them are going to have to be negative. So then to get to the negative 11, the ones that are going to work here are going to be negative 3 and negative 8. That's going to give me x minus 3 and x minus 8. Okay. So we'll do one more here. So I've got this x with 72 on top and negative 17 on bottom. So again, if I'm multiplying to a positive 72 and adding to a negative 17, both of these are going to have to be negative. So 72 has a lot of options I can multiply to it. Those would be 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. A lot of different options. The ones that would give me, again, these both are going to have to be both negative, so all of these numbers would be negative. But the ones that would give me to negative 17 are going to be negative 8 and negative 9. So that'll give me the factors y minus 8 and y minus 9. Okay. So now I'm going to skip it down past a few problems to show you kind of the last thing we need to be paying attention to here. And that is if we have a number in front of our variable here, so like we have a 4 and then the k squared. On this one, we have a 3 and then the y squared, or a 2 and then the b squared. First thing we're going to need to do is see if we can take out a greatest common factor, like we did last week. So looking at this first one, the 4k squared, that would be 1 times 4 or 2 times 2, and k squared is k times k. For the 12k, we have 1 times 12, 2 times 6, 3 times 4, and then the k. And for 8, it'd be 1 times 8 and 2 times 4. So looking at what they have in common, the biggest thing that they all have is 4. So I'll take that 4 out. They don't all have a k, so I can't take out a k. So then I looked at what's left over. This would be 1 and then 2 k's. So that's going to be 1 k squared, or just k squared. For the middle term, we have 3k left over. And since this is a plus, it'll be plus 3k. And then finally, with the last term, what's left over when I take out the 4 is a 2. And again, this would be a plus, so plus 2. So we factor out that 4. Then what I'm going to need to do is, once I've taken out that greatest common factor, is I'm going to need to factor what's left over. So what's in the parentheses, after I take out that 4, I'm going to need to factor that part. So what I'm going to do is set up this x with the 2 on top and the 3 on the bottom. Find the numbers that multiply to 2 and add to 3. The only numbers that multiply to 2 are 1 times 2, so those are going to be my numbers here, 1 and 2. That gives me the factors k plus 1 and k plus 2, which normally we would be done, but in this case, since we took out a 4 as the greatest common factor, we need to make sure to bring down that 4 into our answer as well. It's going to be 4 and then k plus 1 and then k plus 2. So I'll do number 25 as well. Since we have a number in front of that y squared, we should see if we can take out a greatest common factor. This would be 1 times 3, and then y times y. For the 15y, it'd be 1 times 15, or 3 times 5, and then y. And for 12, it's 1 times 12, 2 times 6, and 3 times 4. So looking at these, the biggest number they all have is 3. So I would take out a 3. And again, they don't all have y, so I can't take out a y. So then I look at what's left over. This one would be 1 with 2 y's, so that would be 1 y squared, or just y squared. This one would have a 5 and y left over, but in this case it's a negative, so minus 5y. And then for the last one, when I take out the 3, we have a 4 left over, and this one is a plus. So this one would be plus 4. Okay, so then once I take out that factor, I'm going to need to factor what is left over, or what's left in the parentheses. So I set up the x with 4 on top, this negative 5 on bottom. So if I'm multiplying to a positive 4, adding to a negative 5, that again tells me both of my numbers are going to need to be negative. The numbers that multiply to 4 are 1 times 4 and 2 times 2. So to get to negative 5, I'm going to need the negative 1 and negative 4. That gives me factors y minus 1 and y minus 4. And again, normally we'd be done, but we got to remember to bring down this 3 that we took out at the beginning. So that 3, that's the greatest common factor, needs to be in our answer as well. So that's going to be it for the notes for this video. Again, remember to make sure you're doing these even problems on your own. So all of these problems on the right side, 10, 12, 14, 16, etc., these are the problems that you need to do on your own. And let me know if you have any questions.